So right here we have a diagram of an atom, and it wants us to give different properties of this atom. So it wants us to say its atomic number, mass number, whatever. Okay, so let's see, atomic number. Well, we know atomic number is the number of protons, right? And we have the key here that gives us the protons are the black circles. So if we count the black circles, we see 1, 2, 3, 4. So we know there's 4 protons there. And it says that the number can be used more than once, so we won't cross out 4 yet. So then we have the mass number. Well, we know the mass number corresponds to the total number of protons and neutrons in the nucleus here. So we're just going to count all the circles in the nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9. And with 9, we have our next answer. And if you have having trouble counting this, just remember that in the actual test, it'll be a lot more clear to you. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9. So definitely 9. Okay, next we have period number. Remember that period number, people often forget this because we're too often remember group number, not period number. But period basically refers to the number of shells in this case, so it'll just refer to how many shells the atom has. So we count 1, 2 shells, so we know it's in period 2. And now this says number of electrons in the 2+ ion formed from this atom. So you can see the number of valence electrons is 2. It's asking the number of electrons in the 2+ ion formed from this atom. We know it's also going to be 2. And there we go. Scroll down. In terms of subatomic particles, there's similarity and difference for isotopes of the same element. Very simple question, just theory. What's the definition of isotopes? So they're atoms of the same element with, well, many ways you can say it, but the same atomic number but different mass number is one way to say it. But generally, the nicest way to say it is the same number of protons. I don't know why it's caps, but we'll leave it like that for this question, I guess. So the same number of protons, but they differ in the number of neutrons. Simple definition question, basically, just test your knowledge. You should be getting that easily. Next up, we have a question about apparatus. Okay, apparatus used, and it wants us to define what these two apparatuses and their units. Okay, sure. So this one, we can tell just by how it looks. It's a gas syringe. You can see the little syringe parts, and yeah, clearly a gas syringe. And for the unit for gas syringe, we should know that it's in centimeters cubed. If you want, you can say in milliliters. They're equivalent, so just whatever. But some centimeters cubed is generally the nice one to say. And next up, we have a balance. Many ways you can say this: weighing scale, balance, top pan balance. Many ways. I'm just gonna say weighing scale. But yeah, just keep it simple. Don't try and go excessive. But there are many ways you could say this one. And as for the mass, generally it's best to go grams because that's what's usually in. You can tell from the significant figures it's probably going to be grams. But they allow milligrams also as an answer for this, so you can go with it with whatever you want. Okay, next up, we see that the diagram shows apparatus used to obtain pure water from sodium chloride solution. Okay, simple distillation. Yeah, pretty simple. Explain why it's necessary for water to flow continuously in and out of the apparatus. Okay, this is good. So this is a pretty standard, simple distillation setup. It'll always look like this generally. And it wants us to know why water is flowing in and out continuously. Well, why does water have to flow in the first place? Well, water is flowing to cool the water. To cool the vapor. Because you can see the sodium chloride is going to condense, it's going to evaporate, go up, go here, and then inside of this condenser is going to be condensed and go into the conical flask. So what is the role of water coming in and out? Well, it's to cool the water vapor so that it condenses. The wording of this question may confuse some people, but to be honest, it's pretty simple. The water is there just so that it can cool the vapor that's entering so that it condenses, and then we can get pure water at the end of the system. Okay, describe a chemical test to show that sodium chloride contains chloride ions. Okay, chloride ions. Well, we should know that to get chloride ions, we need to do the silver nitrate. We need to add silver nitrate. So AgNO3. solution needs to be added. Okay, and this is just the theory, but you should know that if you add AgNO3, the positive test to show that it contains chloride ions is that a white precipitate will form. This one, unfortunately, this one's just theory. There's no other way to think about it. It's just how you need to know. You need to know your syllabus. You need to know how do these chemical tests. Okay, describe a physical test to show the liquid is pure water. Now this should be really easy. Remember, when they say physical test and water, you should instantly think to your head boiling point. That is the main thing in your head. So you can measure the boiling point, and then what should it be? Well, the boiling point should be 100 degrees Celsius if it's pure water. Also, likewise, you can also say you can measure its freezing point and it will be 0 degrees Celsius. Both work, but for me, I like to just think of it as boiling point because that's just it's more intuitive for me.